Let's learn how to solve this nice maths Olympiad problem. We're asked to find the whole roots of x. Now, to go ahead solving this, we're going to see how we'll bring the left-hand side straight to the right-hand side straight to the left-hand side. And when we do that, we are going to have this expression to now become x to the power of 4. That will be minus bracket x minus 1 and all to the power of 4, and this will be equal to 0. Great. Now, having achieved this, I want us to bear in mind two things. That 4 can be equal to, if we check 4 can be equal to 2 multiplied by 2, right? So if 4 can give us 2 multiplied by 2, that means we can replace 4, very well we'll find 4 in that expression with 2 multiplied by 2. So that means this expression will now give us the value of our x all squared multiplied by square the power of 2 multiplied by we'll have x minus 1 all squared, and all of these will be what? Squared, and this will be equal to 0. Great. Now, having seen this, now what we are now going to do is to apply a simple algebraic law, and we know what we have as a difference of 2 squared. Now, this looks like a difference of 2 squared. Remember this rule in algebraic formula: if we have a square minus b square, this can be equal to a plus b, right? And then we'll have a minus b. So if we have that, considering this as a difference of 2 squares, we'll find out that a is equal to x squared, right? And then b will be equal to x minus 1 all squared, right? So having these two expressions, we can simplify further. So we are going to simplify this, knowing that we have our value of a as x squared and b as equal to x minus 1 squared. So that expression will give us this value. We will now have this value. We'll have our x squared as a minus, let's go with the addition first, plus x minus 1 all squared, right? That's the first expression. And this will be multiplied by x squared, right, minus multiplied by x minus 1 all squared, and this will be the second expression. Great. So we are going to solve this, and remember that all this is equal to 0. So we are going to expand this expression. Now recall that if you expand this expression, we are going to have that expression to now give us, we'll have x squared plus, we'll have x squared minus 2x plus, right, if we expand that, plus 1, right, and this will now give us x squared minus, since it's a negative sign there, we'll have to put that bracket, x squared minus 2x plus 1, and all these will be equal to 0. Now let's expand this expression. If we expand that expression, we're going to now have this expression to now give us this plus this, x squared plus x squared will now give us 2x squared, right, minus 2x plus 1. That's on one side. And then on the other side, we'll have x squared minus times x squared will give us minus x squared. Minus times minus 2x will give us plus 2x. And then we'll have minus times plus 1 will give us minus 1. And all this will be equal to 0. So let's simplify further. We're going to have 2x squared minus 2x plus 1, and then we'll have this to become x squared, definitely we'll have to clear x squared, right? And then we'll be left with what? 2x minus 1, and this will be equal to 0. Great. Now, how do we go about simplifying this? This is what we call the zero product rule, and then we are going to bring out these two expressions. The first expression will have the value of 2x squared minus 2x plus 1 is equal to what? 0. And from the second expression, the second case, we'll have 2x minus 1 to be equal to 0. Great. So if we simplify these two expressions, we are going to have all the values of x. Now let's start with the quadratic equation. With the quadratic equation, we're going to solve using the quadratic formula. Now I want you to note that this expression is just like this expression, ax plus bx plus c, and that will be equal to 0. So from this expression, a is equal to 2, b is equal to negative 2, and our c is equal to 1. So if we insert that into a quadratic formula, the value of x will be equal to negative b plus or minus square root of b squared minus 4ac, and all this will be divided by 2a. So let's insert those values of a, b, and c into the quadratic formula. So that will give us x to be equal to negative 2, right? All multiplied by a negative externally, plus or minus the square root of negative 2 squared minus 4 multiplied by a is 2 multiplied by 1, c is 1, and all this will be divided by 2 multiplied by 2. So if we simplify this, we're going to have the value of our x to be equal to 2 plus or minus times minus will be plus the square root of negative 2 squared is going to give us 4 minus 4 times 2 is 8, and all this will be divided by 4. So if we simplify this, we are going to have the value of our x to be equal to 2 plus or minus the square root of negative 4 all divided by 4. So what do we have from here? You're going to see that from here, the value of our x is equal to 2 plus or minus the square root of 4, right, multiplied by the square root of negative 1 divided by 4. Now, having seen this, let's simplify. The value of our x will now be equal to, recall that j, the square root of negative 1, is equal to imaginary. So we'll have that expression to now give us 2 plus or minus square root of 4 is 2 imaginary, and all this divided by 4. So the value of our x will be equal to 2 divided by 4 plus 2 imaginary divided by 4, and we'll take this as our x1. So if we go up there, we're going to take the second one as our x2. When we have this, we'll have this as our x2. Our x2 will now be equal to 2 divided by 4 minus 2 imaginary divided by 4. And you know, if you simplify these two expressions, you can have your x1. We can now have our x1 to be equal to 1 divided by 2 plus imaginary divided by 2. And our x2 will be equal to 1 divided by 2 minus imaginary divided by 2. So these are the two first roots of that expression given to us. Now let's look at the next value, the next case. In the next case, we are given that 2x minus 1 is equal to 0. So if 2x minus 1 is equal to 0, and we decide to subtract, add 1 to both sides, we'll have 2x minus 1 plus 1 to be equal to 0 plus 1. So if this clears this, we'll have 2x to be equal to 1. So if we divide here by 2 and divide here by 2, you find out that the value of our x, when this clears this, x will be equal to, and we'll make this to be x3, will be equal to 1 divided by 2. And that will be the only real solution to that expression. So over here, we will now have our x3. The next solution, our x3 will now be equal to 1 divided by 2. Now let's check to see if our solution to this expression is absolutely right. From the initial expression we are given, from the initial value, we are given that x to the power of 4 is equal to x minus 1 all to the power of 4. So let's check if these solutions will give us that. Let's check if we put the value of, let's check with the value of our x equal to 1 divided by 2. Remember, we are given that x to the power of 4 equal to x minus 4 minus 1 all to the power of 4. So if we insert the value of x equal to 1 divided by 2, can we make up that the right hand side be equal to the left hand side? We have 1 divided by 2 all to the power of 4 equal to 1 divided by 2 minus 1 all to the power of 4. So if we simplify that, we'll have this to be equal to 1 divided by 16, right? While this will be equal to, simplify this, we'll have this to become negative 1 divided by 2 all to the power of 4. And if we simplify that, we'll have 1 to the power of 16 equal to, this is going to give you negative 2, that will give you minus 2 multiplied by minus 2 multiplied by minus 2 and multiplied by minus 2. And with negative sign being even, this will give us 1 divided by 16. So the value of x3 equal to 1 divided by 2 as the only real solution satisfies that equation that is given to us. So the other two solutions we have are imaginary solutions that also satisfies that equation given to us. I know you did enjoy watching this math solution. Don't forget to like and share this video with friends and colleagues. Remember to subscribe to my channel. That means a lot to me. Do appreciate your watching. Thanks so much and bye bye for now.